Hey guys, so today we'll study about eigenvalues. Eigenvalues. Of course, when it comes to eigenvalues, we also have to learn about eigenvectors. Yes, eigenvalues and eigenvectors. Of course, this comes under matrices. So we use the study of this eigenvalues and eigenvectors in ordinary differential equations while finding the population mean and finding the powers of the matrix, and there also it plays a vital role, eigenvalues and eigenvectors. So what exactly is this eigenvalue and eigenvector? First of all, let us consider a matrix. Let's say a matrix A. Let's write a matrix A as A11, A12, A13 and so on, A21, A22, A23 and so on, and it is a, let's say this is a matrix A. So this matrix, we can express this matrix as Ax is equal to Y. What is this X? So let us take X as a column matrix. A column matrix. I hope you know about column matrix, which means it has only one. It has only one column. So this we call it as a column matrix. And this and the multiplication of these vectors. Let's say we'll get vector. What is it? Matrix Y. That is Y1, Y2, Y3, and so on. Yes. So what is happening here? That is, this column matrix is transforming into another matrix, another column matrix, with the help of this matrix A. So we can write like this. What exactly does this mean? So which means here the matrix X, that is column matrix X, we can write this column matrix X as scalar multiplication by its own, which means I can write this as lambda into X. So which implies Ax is nothing but lambda into X. So this X is nothing but column matrix, and we can write this column matrix as a scalar multiplication. That is, scalar multiplication is nothing but lambda, scalar multiplication of itself. So here this lambda is nothing but eigenvalue. And the vector, that is the column vector that we are speaking, that is X, we call it as eigenvector. Yes, that's it, very simple. So we call this as eigenvalue, lambda, and X as eigenvector. And just let's rewrite this expression once again, that Ax, I can write it as minus lambda Ix is equal to 0. Nothing, we have done that. Here lambda X is there. Okay, I am just multiplying this lambda X with I. I means here identity matrix. When we multiply a matrix with identity matrix, nothing's gonna change. And so this gives one equation, that is, if I write A minus lambda I into X is equal to 0. And this A minus lambda I is called as characteristic equation. Characteristic equation of the matrix. Which matrix? Matrix A. Simple. And using this characteristic equation of a particular matrix, that is A minus lambda I, we are going to find the lambda value, that is eigenvalue. Very simple, very convenient. Yes. So just for learning purpose, let's write some important properties of eigenvalues, that is nothing but lambda. Let me write it as lambda. Okay, the first important property is, let's go it in a brief way. So for any square matrix, for any square matrix, let us consider any square matrix A and its transpose. Transpose is nothing but A transpose. They both have same eigenvalue. They both have same lambda, same eigenvalue. This is one of the properties. And the second property is the sum of the eigenvalues of a matrix is equal to the trace of the matrix. I hope you know what is the trace of a matrix. That's right, trace of the matrix. These properties will be very helpful while we find out the many problems we can solve by using only these simple properties. If we know these simple properties, we can solve many problems. Okay, first let's study what is a trace. For example, A is equal to let's say 1, 0, 2. Just an example, okay? 2, 2, 3, 1, 2, okay, 5. Okay. Here, trace of a matrix means it is the sum of the diagonal elements. The sum of the diagonal elements, that we call it as trace of this particular matrix A. For example, here the trace is nothing but 1, 2, 5. That is diagonal elements, sum of diagonal elements. So that is nothing but 8. Here the trace of matrix is 8. Okay, we came to know about the trace of matrix. So what is the connection between lambda and trace of matrix? So the trace of the sum of lambda, the sum of all the lambda, that is, for one matrix there may be 2, 3 lambdas eigenvalues, depends on the matrix. So the sum of all those eigenvalues is equal to the trace of the matrix. So this is one of the helpful properties that we use to solve many problems. Okay, let's go for the last another property, that is third property, the product of the eigenvalues. Okay, the product of the eigenvalues, the product of lambda eigenvalues is equal to determinant of a matrix. Okay, determinant of a matrix A. So these are the important properties that we'll find helpful in solving many problems. So this is about the introduction of eigenvalues and its properties, and in the next video we will study about some of the important problems related to eigenvalues, and these eigenvalues and eigenvectors are very simple. We'll try to solve them in the next session. So happy learning.